A pleasant afternoon, everyone. This is the group of our foreigners, and we will discuss the first part of topographic surveying about the representation of relief and the type of contours. The representation of relief can be defined as an imaginary line connecting points of equal elevation on the ground surface. The methods of representation of relief includes sugar loaves, hatchers, hypsometric tins, shaded relief, Tanaka contours, block diagrams, and contours. Topographic maps is a data that composes the elevation and the height in a specified area or place. The map shows the configuration, the shape, and the roughness of the land. The roughness is commonly referred to as relief. The depiction of the relief in the land would change throughout time. Topographic surveying is involved in the procedures of using equipment and methods that are required to obtain both vertical and horizontal data points of the land. In the modern topographic maps, there are lines that represent as points containing identical elevation, with the lines as called contours. The elevation of lines is based on the known or assumed datum. Sugar loaves are a refined sugar in the form of a rounded cone. They were used in the pre-1700s as these were the idealized depiction of an oblique view. This can be seen in the early topographic map. Due to the lack of detailed surveying, this would only give the location of the mountain or hills, but not the precise size. Hatchers are strokes drawn in the direction of the steepest. Steeper slopes are represented by thicker, shorter strokes, while gentler slopes are represented by thinner, longer, and farther apart strokes. They were systematized in 1799 by Major Lehmann, an Austrian military officer, where line width became directly proportional to the steepness. This was the main type of relief depiction through the 19th century. After accurately surveyed heights became more available through the 20th century, hatchers gave way to contours, but they are still used for very steep slopes such as cliff, prairies, railway cuts, where the contour lines would merge. These are the advantages and the disadvantages of hatchers. Its advantage is that they show minor but important details. Its disadvantages is that they lack absolute information, difficulty in distinguishing the direction of the slope, time consuming to produce, obscures other information, and not very effective except in mountainous terrain.
The third method of representation of relief are the hypsometric tins. These are colors placed between contour lines to indicate elevation. The addition of color to elevation levels was first tried as early as 1830. To add to this, color schemes require graduation, logical sequence, realistic colors, with the darkest still able to bear readable text. These are the advantages and disadvantages of hypsometric tins. For advantages, it adds imageability, mostly at a small scale, and it is easily applied and understood. For disadvantages, it includes exaggerated terrace effect with no new real information added. Next is the differential contrast between tints and other elements and dubious color associations. Lastly, the individual may have a hard time picking which color scheme, chroma of hue, and spectrum range will be used. The next method of representation of relief is the shaded relief or hill shading. It is defined as the method of representation of relief that shows the shape of the terrain in a realistic fashion by showing how the three-dimensional surface would be displayed from a point light source. This involves the addition of shadows to give the illusion of depth, assuming the theoretical northwest light source at 45 degrees elevation. It was first introduced in the 1900s but became more widespread after 1960. With the improved printing technology and user needs, it became much more common with automation. These are the advantages and disadvantages of shaded relief or hill shading. For advantages, it has high imageability, continuous in appearance, can show greater detail, and character of landscape suitable over a variety of scales, and as a general background for a variety of map types. For disadvantages, It requires artistic creation with pencil or airbrush. It is costly and often poorly rendered when done manually. It creates a variable background with some slopes very dark. Next is the Tanaka relief contours. It is a method of representation of relief that applies light source to a contour map, typically at 300 degrees or another northwestern direction. The result is a 3D-like representation that helps users visualize terrain and be able to effectively distinguish concave from convex landforms. To add to this, it was first tried in 1850, but printing methods then could not handle gray backgrounds. It was then pioneered in the 1950s by Kitiro Tanaka, who produced some exquisite examples using the theory of application of shading principles to contouring. The last method of representation of relief are block perspective diagrams. It is often described as the representation of a landscape in a perspective projection. The art of a block diagram construction defined these illustrations as plain figures that represent an imaginary rectangular block of the Earth's crust in what appears to be as a three-dimensional perspective. This method of representation of relief was also first introduced in the early 1900s. These are the advantages and disadvantages of block perspective diagrams. For advantages, it is the most imageable portrayal of landscape, often used for ski hills and panoramas. For disadvantages, it is the most time-consuming to produce with no consent linear scale before computers.
So now we will be discussing about contours. Contours came initially from the need to know exact depths in water and were generated from a series of depths or soundings. The first contours in the late 1900s were on navigation charts as isobaths, since hashering was not suitable for an unseen landscape. A contour is essentially an isorhythm or an isopleth, a line drawn on a map through all points having the same numerical value as at the population figure or geographic measurement. The characteristics for contours are the following. The contour interval, which is the distance between contour lines, is determined by terrain and map scale. For index contours, they are symbolized as wider lines and are usually in every fifth contour. Form lines are approximate elevations, which tells us that these are not accurately surveyed. Depression contours, enclosing lower land, are drawn with small tick marks inside. The basic rules for contour lines is that a contour line must never split or divide. A contour line must never simply end except at the edge of the map. A contour line must represent one and only one elevation. A contour line may never intersect other contour lines. Overhanging cliffs are the only exception. Contour lines form a V pattern crossing stream that always points upstream. They are closely spaced. The closely spaced contour lines represent a steep slope. Widely spaced lines indicate a gentle slope. Concentric circles of contour lines indicate a hilltop or mountain peak. Concentric circles of hachured contour lines indicate a close depression. Here are the advantages and the disadvantages of contours. The advantages of contours is that it is the most commensurable quantitative method. It is the origin for many new depiction techniques, and it is now familiar to many users. Its disadvantages is that it is an abstract method where there are no counterpart to lines on ground, and it is poorly suited to small scales. It is less imageable, but depending on contour interval, map scale, landscape type, and user's experience. There are 5 types of contours: the index, intermediate, supplemental, depression, and the approximate contours. The index contour is used to make topographic maps easier to read. These are bold or thicker lines that appear at every fifth contour line. Because of its impractical to mark the elevation of every contour line on the map, the index contour lines are the only ones labeled. The index contours are a darker or wider brown line in comparison to the regular contour lines. If the numbers associated with specific contour lines are increasing, the elevation of the terrain is also increasing. If the numbers associated with the contour lines are decreasing, then it means that there's also a decrease in elevation.
The second type of contours is the immediate contours. The contour lines falling between the index contour lines are called immediate contour lines. These lines do not have their elevations and number labels given. There are normally 4 intermediate contour lines between index contour lines. In part of the map where intermediate contours are closely spaced as to nearly unite or merge into a single line, it is customary not to portray the lines for a short distance for readability. This technique is called feathering. The third type of contours is the supplemental contours. Supplementary lines appear as dotted lines, indicating flatter terrain. Peak ring, the innermost ring at the center of several contour loops, almost always represent a peak, which is the highest elevation. Supplementary contour lines are placed between regular contour lines to visualize small but important forms that regulate contour lines are unable to show. On topographic maps, typical forms are hill crest, depressions, saddles, terraces, banks, and leaves. The fourth type of contour is the depression contours. Depression contours is a closed contour. This is represented by a series of concentric closed contours, with the inner contours having lower elevation than their outer surroundings. There are small tick marks or hatcheries on these contour lines pointing towards the lower elevation. One of the uses of depression contours is to show low spots around which contours close. The last type of contour is the approximate contours. Approximate contours is a contour substitute for a normal contour that is approximately determined whenever there is a question as to its reliability. Reliability usually is evaluated as exceeding 1/2 the contour interval. These are used when contours cannot be drawn accurately, possibly due to inaccessibility of the area, which is based on the educated guess of the maker of the map.